So I'm going to start off with a quick review of I'm not going to do a full review of what we did last week, but I just want to do a quick review of the material that I'm going to use in this lecture, so that if you've forgotten or if it's not fresh, आपके ज़हन में एक दफ़ा वो चीज़ दोबारा आ जाए. Starting off with logic gates, number systems we'd spoken about how decimal numbers and binary numbers are different. Then we'd moved on to how to convert decimal to binary and binary to decimal. So हमारे पास जो base थी, that was 0, 1, 2, 3, 4, 5, 6, 7, 8, and then on the left hand side you see the representation of your binary numbers. So this was very basic. Then we'd spoken about how numbers are represented in terms of powers of 2. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and so on and so forth. And all of these numbers basically mapped into their decimal equivalents. So इनकी representation हम binary में करते हैं. So ये हमने एक छोटी सी exercise की थी पिछली class के अंदर, just to make sure that for those of you who done binary a while ago, this could be refreshed. And then we did a quick exercise which was a binary to decimal conversion. उस exercise के बाद जो है we then moved on to the meat of our class, which was addition. So I want to go straight into addition. There we go. अब एडिशन के लिए I think हमारे पास सबसे आसान तरीका ये है कि हम एक बेस केस लेके चलना चाहते हैं, and that base case is हमारा जो बेस केस है एडिशन का, वो is adding a 4-bit number, two 4-bit numbers. So this is number 1. So our first number, and let's just call it number A, and then I have another number, and let's call this number B, and then this is my result. और अगर आपको याद हो तो हमारी बेस क्या है? हमारी बेस starts off with 1, 2, 4 and 8. So there's the base, right? Now the question comes up that when you have two binary numbers that you're trying to add, and the numbers that you have, so इस specific case के अंदर, let's say we have the number that we have is 1, 1, 1 and 1, and number B is also 1, 1, 1 and 1. And इस specific instance के अंदर, what we want to do first is we just want to walk through how this process works. We want to make sure we understand how this simple 4-bit key addition works. Once we understand how this simple 4-bit key addition works, and we have a high-level truth table to work with, then we can go out and try and implement that as a circuit. The first set, these bits, they represent the first bit and they represent the number 1. So अगर ये दोनों number A and number B दोनों 1, 1 है, तो output क्या आएगी? जब आपकी output दो हिस्सों में आएगी, right? एक is the value sum, so I'm going to write this down here, and एक is what I call carry. तो अगर हम एक और एक को ऐड करेंगे तो हमारे पास क्या आएगा रिजल्ट? In the binary base, when you add 1 and 1, what would be the resultant value? What would be the sum? So Rushna says it's going to be 1, 0, Hamna says it's going to be 1, 0. Now when you think in terms of 1, 0, you actually have to break this down, right? So अगर आपके पास एक ही bit है, you have to remember, आपके पास bit एक ही है, right? I'm going to color code this. ये मेरी पहली bit है. So अगर एक bit है तो एक bit का जवाब आपके पास 2 bit में तो नहीं आएगा. You actually, as far as this first bit is concerned, this first bit का जवाब is actually going to be 0. यहाँ पे 0 आएगा और ये carry जो है ये 1 हो जाएगा, right? So अगर आप numerically represent करेंगे तो you basically saying कि जब मैंने 1 और 1 को plus किया तो मेरे पास जवाब आया 1 और 0. And इसको हम कैसे represent करते हैं? ये हमारी दो inputs हैं, इसके ऊपर हमने अपना operand apply किया, हमारे पास output जो है वो 2 bit की आई. एक bit जो है, ये वाली जो bit है जो 0 लिखा हुआ है यहाँ पे, this is sum, and जो दूसरी bit है, this is carry. I know this is very basic, I know this is a refresher, but this is very important. I think कल भी जब मैं when I was teaching this class, I I said this to my students that with digital circuits, with logic design, with basic electronics, it often happens that everything is crystal clear, it's making perfect sense to you, and then suddenly, it's like somebody turns off a light switch and you're lost. So I want to make sure that this fundamental operation, the addition of 4 bits, is completely clear in our head. We understand how the output is represented, we understand how it's calculated, we understand how it leads to the results that we have, and only then will we be able to build the circuits that we want to build. पहली bit का आपके पास जवाब आ गया. Now we move on to the second bit, and this is the bit that represents the number 2 on a decimal basis. इसको भी हम color code कर लेते हैं. So let's say this is now marked as blue. तो अब क्या हुआ? अब आपके पास यहाँ पे I'm going to put in a term here. I'm going to call this carry in, and I'm going to call this carry out. ये जो आपके पास कैरी यहाँ पे आया है, जो कैरी आउट है, ये सेकंड बिट का क्या हो जाएगा? दिस इज गोइंग टू बिकम द कैरी इन फॉर द सेकंड बिट. सो आपके पास 3 1s हैं. बिट्स आपके पास 2 ही हैं. एक आपके पास बिट है कैरी के लिए, एक आपके पास बिट सम के लिए. तो जब आप इन तीनों को ऐड करेंगे, फॉर एग्जाम्पल वी जस्ट टेक दीज 2, तो यू शुड स्टिल गेट 1 and 0, बट देन यू स्टिल हैव अ थर्ड one left, which is this one. When you add this together, so the sum value would be 1 and your carry out would also be 1. फिर आपके पास 3 1 हैं और आप 3 1s को ऐड करें, तो the end result is going to be what? 1 1. जैसे अब यहाँ पे आपने इधर अगर आप इसको 1 1 1 कर दें, तो ये क्या होगा? ये 1 हो जाएगा, sum 1 हो जाएगा और carry 1 हो जाएगा. I know we did this in the last class, but I want to make sure that we do this one more time before we go back to the circuit again. अच्छा जी, अब then repeat the sequence again. यहाँ पे भी हो जाएगा कि ये जो इसका carry out था from this bit, if I go to the next bit, which is my third bit, I'm going to color code this again, and this is my third bit. इस bit के case के अंदर the sequence is going to be still very similar. मेरे पास, do I have a carry in? Do you see this? ये जो मेरा carry out था, this becomes the carry in here. So I put a carry in here, and then जब मैं इन तीनों को मिलाऊंगा, when I add these again, once I get a sum of 1 and a carry out of 1, and then I get to my final 4th bit, which represents the number 8, and इस bit को भी color code कर लें आप, तो आपके पास 4 bits आ जाएंगे. Right? There you go. That's my 4th bit. And यहाँ पे भी there is a carry in, and where is this carry in coming from? This carry in is coming from the previous bit, right? So यहाँ पे भी 1 हो जाएगा, and then इसके बाद भी there is going to be a carry in, right? So there you go. So from a sequence point of view, there is an output that we produce or number that we track, and we call it carry in, and then there is the actual output which is produced, which is represented by the digit sum, and then we have carry out. तो हमारे पास ये 3 numbers हैं, ये 3 variables हैं that we need to model for binary addition to work. The first is sum, the second is carry out, the third is carry in, and then we've got these 2 numbers, A and B. So अब the next सवाल that comes up, and this is the question that comes up in our mind, is कि now what? So you've done this. Ideally what you want to do is you want to take this to the next stage by building a digital circuit. So if you remember, हमने last time बात की थी कि digital circuit ऐसे नहीं बनाते. आपने ये बना तो लिया, आपने calculation तो कर ली, you've done the addition on your side. What's the first step that we have to do? So आज हम simplification नहीं करेंगे. आज हम पहले सिर्फ truth table और basic design करेंगे, because 7422 ने जिस तरह से हमने कल काम किया था ना आपकी क्लास के लिए, उन्होंने इतनी डेप्थ में जाके लॉजिसिम पे काम नहीं किया है, तो वो जो हमारे कुछ फाउंडेशनल एलिमेंट्स हैं वो भी क्लियर नहीं हुए हैं. तो आई एम गोइंग टू रिव्यू एंड रिवाइज देम अगेन फॉर दिस क्लास, एंड देन वी गो ऑन. तो आई थिंक अगली क्लास में वी कैन टेक अ लुक एट सिंप्लीफिकेशन. आज की क्लास में हम सिर्फ ये काम करेंगे. इफ यू हैव टाइम, सो वी विल टेक अ लुक एट सबट्रैक्शन, एंड वी विल आल्सो टेक अ लुक एट टूज कॉम्प्लीमेंट. सो अब यहाँ पे अगर आप देखें तो आपके पास 2 चीज़ें आ रही हैं, राइट? यू हैव ए एंड बी, ये आपकी इनपुट है, and A and B के पास आपके पास A and B by itself would only have 4 values, which is 0 0 0 1 1 0 and 1 1, right? लेकिन because you look at CN, अगर आप इन तीनों को लेके चलें तो आपके पास 8 वैल्यूज़ बन जाती हैं. तो ये हमारे पास जो टेबल है A B, एंड सो लेट मी जस्ट डू दिस स्टेप बाय स्टेप ताकि यू अंडरस्टैंड. सो A और B की वैल्यूज़ क्या हमारे पास? A और B की वैल्यूज़ हमारे पास दो हैं, 1 और 2. पहली वैल्यू 0 0 है, दूसरी वैल्यू इज़ 0 1, तीसरी वैल्यू इज़ 1 and 0, एंड देन चौथी वैल्यू इज़ 1 and 1, राइट? सो ये तो हम अगर हम सिर्फ A and B को देखें तो हमारे पास ये 4 वैल्यूज़ बन जाती हैं. बट देन इफ़ यू लुक एट C in, and C in would be what? C in would be carry in. अच्छा, अब C in की एग्जाम्पल क्या है? C in की एग्जाम्पल बहुत सिंपल है कि अगर आप एडर बना रहे हैं, जैसे आपने भी यहाँ पे बनाया है, where is, there we go, was this, ये बनाया आपने, right? This is your addition of 4 bits. ये आपने एडर बनाया है, ये आप ये प्रोसेस फॉलो करना चाहते हैं, trying to build this together. So if you build this together, ये आपने बनाया, right? This is the logic gate that you built. This is what you put together. Now the question is कि जब आपने ये बनाया तो इसमें से कैरी इन इधर आएगा और कैरी आउट यहाँ जाएगा. लेकिन जब आप इन सबों को सीक्वेंस में लगाएंगे या साथ में लगाएंगे, या if you want to go from 4 bits to 8 bits, तो फिर क्या होगा? तो फिर you'll actually have to put it together. And then if you let's say go from 8 bits to 12 bits, or from 12 bits or 8 bits to 16 bits and 16 bits to 32 bits, this will essentially daisy chain and put it together. So now when we look at the truth table, जो हमने यहाँ पे बनाया है इधर 2 bits, in this truth table when we add carry in, we now have more choices. तो हमारे पास 4 नहीं रहेंगी, हमारे पास अगर 3 इनपुट हैं तो 0 0 0 0 ये एक आ गया, एंड फिर हमारे पास 4 और आएंगी जिसमें 1 1 1 and 1, ये 8 आ गई. So now A can possibly take these 4 values and these 4 values, and then with this what other options are there? So you could do 0, and you could do 0, and then what would you do? You would do 1 and 0, and then you would do 0 and 1, and then you would do 1 and 1, right? ये आपके पास 4 वैल्यूज आ गई, एंड यही 4 वैल्यूज आप नीचे भी रिपीट कर सकते हैं. तो दिस गिव्स यू योर 8 values. So now you have these 8 values. Now for these 8 values, what do you want to do? You want to calculate 2 elements, which is your output, and those elements are, एक element is carry out, and एक element is sum. ये आपकी आउटपुट है. So जब आप पहली लाइन को, I'm going to number these again, 1 2 3 4 5 6 7 and 8. When I sum A, B and carry in, and I sum all of them as 0, the answer is 0. When I do 0 1 0, the answer is 1. When I do 0 0 1, the answer is 1. When I do 0 1 1, the answer is 0 here, and my carry out becomes 1. The answer here is again 0, and I do 1, and then here again the answer is 0 and 1, and here the answer is again 1 and 0, and यहाँ पे answer would be 1 and 1. Can I explain 4 and 7? Okay, Saad says explain 4 and 7. Okay, so आप आ जाएं पहली चौथी रो पे आ जाएं. So this is row number 4, and then this is row number 7. हम इन 2 रोज को एक्सप्लेन करने जा रहे हैं. अच्छा, अब रो नंबर 4 में क्या हो रहा है? रो नंबर 4 में आपके पास A की वैल्यू 0 है और B की वैल्यू 1 है, और आपके पास जो कैरी इन है उसमें वैल्यू 1 आ रही है. अच्छा, ये जो हम कह रहे हैं ना कैरी इन, ये carry in कहीं, ये carry in is not coming from our sequencing that we're looking at. We're just trying to create combinations of A, B and carry in. They do not represent the sum of the values that we've seen before. These are all possible combinations of values of 0 and 1 between the three variables, so A, B and carry N. Now to simplify it, I can very easily actually just say, I'm not going to call it carry, I'm simply calling it carry. So इस case में it's just going to be three variables, A, B and C. हम जानते हैं कि this is carry N, we using it as carry N, right? But it could very well be A, B and C. But for our perspectives, what we're saying now is we're saying कि अगर मेरे पास ये तीन possible inputs हैं, तीन possible pins हैं, तीन possible LEDs हैं, तीन possible values हैं that can switch between 0 and 1. When I combine all of them together, जिनके सारे कॉम्बिनेशन मिला लेता हूँ, मेरे पास टोटल कितने कॉम्बिनेशन आएंगे? 8 कॉम्बिनेशन आएंगे. उसमें से एक कॉम्बिनेशन है जहाँ पे मेरे पास वैल्यू इज माई इनपुट्स, माई प्राइमरी इनपुट्स आर ए एंड बी, उसकी वैल्यू 0 and 1 है, और मेरी जो कैरी इन की वैल्यू है वो 1 है. तो अब जब मैं इन दोनों को ऐड करूँगा तो मेरे पास आउटपुट क्या आएगी? सम तो 0 ही होगा ना, बिकॉज दिस एड्स अप टू व्हाट? दिस एड्स अप टू, what does this add up to? 1 and 1 का जब आप ऐड करते हैं आपके पास क्या आता है? 0 आता है, and it generates a carry, and this is your carry out. अच्छा, अब now the next question is if you go to 1 0 1 1, right? यहाँ पे क्या हो रहा है? यहाँ पे वही चीज़ हो रही है. The only thing which is different is that rather than B and carry in, हमारे पास A and carry in. So A की वैल्यू 1 है, B की वैल्यू 0 है. तो मेरे पास जो प्राइमरी इनपुट हैं, ये दो प्राइमरी इनपुट हैं, इनकी वैल्यू 1 and 0 which would give me 1, but I also have a carry in. So when I have a carry in, what do I get? I get these two components. So they're very similar to each other. And then the third one, which is line number 8, is कि मेरे पास A and B दोनों 1 है और carry in मेरे पास भी आया है, that's also 1. तो मेरे पास ये तीन 1s आ जाते हैं. तो मेरे पास sum जो आएगा वो sum आएगा 1, और मेरे पास जो आउटपुट आएगी वो आउटपुट आएगी, कैरी आउट जो आएगी वो आएगी 1. What you now need to do is you need to actually break this down into two components. दो आपके पास कंपोनेंट्स हैं. एक है आपके पास ये कंपोनेंट विच इज हाउ डज कैरी. सो इफ यू थिंक इन टर्म्स ऑफ द लॉजिक, जब आप ये सर्किट बनाने जाएंगे तो आपके पास you'll actually have multiple, you'll have sequence of carries, and if you have a sequence of carries, then you need to have some kind of logic, right? Before you get to the sequence of carries, you need to also look at your simple 2-bit addition. So जो आपकी 2-bit addition है, यहाँ तो आपने ये चारों के साथ मिलाई हुई ना, you wrote A, B and carry in. But what if you don't have A, B and carry in? Right, so now I have A and I have B, and I'm only looking at carry. I'm not looking at carry in. I'm just going to look at A, B, carry in sum. So A or B is 0 0, then it's 0 1, then it's 1 0, and then it's 1 and 1. अब इस केस में सम क्या आएगा आपके पास? यहाँ पे सम आएगा 0, यहाँ पे सम आएगा 1, यहाँ पे सम आएगा 1, यहाँ पे सम आएगा 0, और आपके पास यहाँ पे कैरी क्या आएगी? यहाँ पे आपके पास कैरी आएगी 0, यहाँ पे आपके पास कैरी आएगी 0, यहाँ पे कैरी आएगी 0, यहाँ पे कैरी आएगी 1. So what I've done is, rather than work with the 3 inputs, I've now taken a step back, simplified it. I'm just looking at A, B. So A and B is my, so this is A and B is my input, and carry and sum are my output. अच्छा, अब आपको याद तो होगा हमने we spent some time on trying to understand and trying to remember the gates that we'd worked with, right? So sum के केस में when you look at this gate, ये अगर output है आपके पास, तो ये आपकी output है और ये आपकी input है. So what does this output look like? If I give you a logic where that says कि अगर मैं आपको 0 0 दूँ तो आपके पास 0 आएगा, 0 1 दूँ तो 1 आएगा, 1 0 दूँगा तो 1 आएगा, 1 1 दूँ तो 0 आना चाहिए. What does this logic look like? Is there a gate that can model this behavior for you? You've seen that gate before, right? So we can represent the logic of the sum by a XOR gate and then look at carry. What does carry look like? अगर मैं आपको 0 0 दूँ तो आपके पास वैल्यू 0 नहीं चाहिए. If आपके पास मैं 0 1 दूँ तो should be output should be 0. 1 0 दूँ तो output should be 0. 1 1 तो output should be 1. This looks like a, so this looks like a this looks like an AND gate. Perfect. So you have an AND gate and then you have a ZOR gate. तो ये दो गेट्स हैं आपके पास. तो अब हमारा गेम प्लान क्या? हमारा गेम प्लान ये है कि हम ये AND गेट और ZOR गेट को लें, इसको इस्तेमाल करें और इसकी बेसिस के ऊपर क्या करें, इसकी बेसिस के ऊपर हम लॉजिसिम में चले जाएं.